Now let us find epsilon x at all these 4 points. Okay, 1 comma 1, minus 1 comma 1, 1 comma minus 1, minus 1 comma minus 1. Okay, so u is given, v is given. Now we have to find epsilon x, epsilon y, and gamma xy. So this is epsilon x, dou u by dou x. We have partially derivated u with respect to x. So epsilon x is got, we got epsilon x as 3 plus 12x squared plus 6y square. 3 plus 12x square plus 6y square. So what is epsilon x? At 1 comma 1 first. 3 plus 12 into 1 squared plus 6 into 1 squared. How much is that? 3 plus 12 plus 6. How much is that? 15 plus 6, 21. What is epsilon x at 1 comma minus 1? What is epsilon x at 1 comma minus 1? 3 plus 12 into 1 square plus 6 into minus 1 whole square. Minus 1 whole square is 1. So 12 plus 3, 15. 15 plus 6 is 3 plus 12 plus 6. That is 21. 21. Next, epsilon x at minus 1 comma 1. So that is 3 plus 12 into, in place of x substitute minus 1. That is minus 1 whole square plus 6 into 1 square. So minus 1 whole square is 1. So 3 plus 12 plus 6 is equal to 21. Epsilon x at minus 1 comma minus 1. How much is that? 3 plus 12 into, in place of x substitute minus 1. Minus 1 whole square plus, in place of y substitute minus 1. Minus 1 whole square. Minus 1 whole square is 1. So 3 plus 12 plus 6. That is equal to 21. So now you can see here epsilon x, the strain in x direction, normal strain in x direction is same in all the edges. Normal strain in x direction is same in all the edges, which is 21. Okay. Now let us find out epsilon y. Epsilon y. One second. Now let us find out epsilon y. What is epsilon y? Xy minus 7x squared. Right? Oh, sorry, this is v. V is equal to xy minus 7x squared. What is epsilon y? Epsilon y is dou v by dou y. So we have to partially derivate v with respect to y. So dou by dou y of what is v? Xy minus 7x squared. So we are partially derivating with respect to y. So x should be treated as constant. So constant into derivative of y with respect to y is 1. So x minus, it is completely x terms. We are partially derivating with respect to y. So 0. So that is equal to x. So epsilon y at 1 comma 1 is equal to, you have to, there is no y term. So only first coordinate will be substituting. So 1. Epsilon y at minus 1 comma 1, that is equal to minus 1. Epsilon y at 1 comma minus 1, that is equal to 1. Epsilon y at minus 1 comma minus 1 is equal to minus 1. And you see here, even in the normal strain in y direction is also same. It's not changing in magnitude, but of course direction will change, but magnitude it is same. Epsilon y is same. Both normal strain in x direction and normal strain in y direction, both are constants. Both magnitudes are the same. Now we got epsilon x and epsilon y. Now let us look into gamma xy. What is gamma xy? Gamma xy is equal to, we all know what is that. Okay, displacement in x is u, displacement in y is v. So if you take product, cross, if you take cross, starting from bottom, dou v by dou x plus dou u by dou y. Right? Now let us find out dou v by dou x first. What is dou v by dou x? Partially derivating v with respect to x. So dou by dou x of what is v? Xy minus 7x squared. So we are partially derivating with respect to x. So y is constant. So derivative of x with respect to x is 1. 1 into y is y minus derivative of x, 7 is constant, derivative of x square is 2x. So 7 into 2x is 14x. So minus 14x. So this is y minus 14x. What about dou u by dou y? We have to partially derivate u with respect to y. So dou by dou y of, what is u? What is u? U is 1 plus 3x plus 4x cubed plus 6xy square. 1 plus 3x plus 4x cubed plus 6xy square. So we are partially derivating with respect to y. So x terms will also be treated as 0. So this term would be 0 and this term would be 0 and this is again constant 0. So 0 plus 0 plus 0. We are partially derivating with respect to y. So x should be treated as constant. 6 is constant. So 6x constant. Derivative of y with derivative of y squared is, derivative of y squared with respect to y is 2y. So 2y into 6x is 12xy. 12xy, right? So therefore dou u by dou y is equal to 12xy. Therefore what is gamma xy? Gamma xy is dou v by dou x plus dou u by dou y. What is dou v by dou x? We already got. How much we got? Y minus 14x. Plus what is dou u by dou y? Dou u by dou y plus 12xy. So this is your gamma xy expression. What is that? Gamma xy is equal to y minus 14x plus 12xy. Right? So now let us find out the shear strain gamma xy at all those 4 points, edge points. Okay. So let us take gamma xy. So take gamma xy. Gamma xy, how much we got? Y minus 14x plus 12xy. Y minus 14x plus 12xy. Okay. So first let us find out gamma xy at 1 comma 1. How much is that? 1 minus 14 into 1 plus 12 into 1 into 1. How much is that? 1 minus 14 plus 12. How much is that? How much is this? 1 plus 12. 13. 13 minus 14 minus 1. So gamma xy at 1 comma 1 is equal to minus 1. Right? Gamma xy at minus 1 comma 1. How much is that? Substitute in place of x minus 1, in place of y 1. So how much do you get? How much do we get? In place of y 1 minus 14 into in place of x minus 1 plus 12 into in place of x minus 1 in place of y 1. So how much is this? 1 plus 14 minus 12. So 15 minus 12, 3. So therefore gamma xy at minus 1 comma 1 is equal to 3. Okay. Similarly, let us look for 1 comma minus 1 and minus 1 comma 1. Okay. So what is remaining? Gamma xy at 1 comma minus 1, that is equal to 1 comma minus 1. Okay. So what is actually gamma xy? Gamma xy is equal to y minus 14x plus 12xy. Right? So now substitute in place of x1 and in place of y minus 1. So what you will get? Minus 1 minus 14 into 1 plus 12 into 1 into minus 1. So what you will get? Minus 1 minus 14 minus 12. How much you get? Minus 15 minus 12 minus 27. So gamma xy, what is last point remaining? Minus 1 comma minus 1. So in place of y, in place of x substitute minus 1, In place of y, substitute -1. So what you'll get? What you'll get? -1 minus 14 into -1 plus 12 into -1 into -1. -1 plus 14 plus 12. How much is that? 26 minus 1. That is 25. Right? Therefore, so we got the strain in all the four. We got the strain in all the four corners, right? In all the four corners, we got the strain. And now, where the strain is more? At this particular point, the shear strain is more compared to normal strain. We got epsilon x. We got epsilon x 21. We got epsilon y only 1. But we got strain at one particular point, 1 comma minus 1 is 27. Of course, it is minus 27, right? So strain is high or strain is more. Shear strain is more at this particular point. What is that point? Shear strain is more at this particular point, 1 comma minus 1. At this particular point, shear strain is more, right? So this is what we are asked to find. Determine where strain is more on the element. Of course, we got the expressions for epsilon x, epsilon y. We wrote it, right? So this is the expression for epsilon x, and this is the expression for epsilon y, and this is the expression for, and of course, what is that? Yes, this is the expression for, and this is the, where is that? I'm also one second. Yes, this is the expression for gamma xy, and in those epsilon x, epsilon y, and gamma xy, we have substituted all the 4 points. That is 1 comma 1, all the 4 edge points. 1 comma 1, all the 4 edge vertices, I should say. 1 comma 1, minus 1 comma 1, 1 comma minus 1, and minus 1 comma minus 1. And we got the strain at this particular point, 1 comma minus 1. That is the shear strain at 1 comma minus 1. What is that point? This point, shear strain at this particular point is high. Okay. So thank you so much for listening to this particular lecture. And in the next class, again, we'll do the problems. We'll do the problems on plane stress and plane strain. Okay. Is that clear? Thank you. And CR.
Sir.